So we are looking at the logit model, and we are looking at the three ingredients of the logit model: the choice set, Cn, the epsilon in, the error term, and the vin, the deterministic part of the utility function. In the previous video, we looked at the choice set. In this video, we will look at the epsilon in. Actually, for the epsilon, we will do the same assumption that we did for binary logit. We will assume that these epsilon in are random variables that are independent, and by independent I mean independent across alternatives I, but also across individual n, and that they are identically distributed as an extreme value distribution with location parameter 0 and scale parameter mu. Okay, so it's important to understand that this independence assumption goes into both dimensions across alternatives I and individuals n. The fact that it's an identical distribution, it means that the mu parameter, the scale parameter, is the same for all individuals n and all alternative I. And as we will see, this parameter mu, the scale parameter, will not be identified from data. So in practice, when we estimate the model from data, we will have to normalize its value to 1. But in the derivation, I will keep it as such, so because it's there and it's important.